So in the last three presentations, we had discussion on the basic circuit element capacitor. Now in this presentation, we will be talking about the basic circuit element inductor. So basically, what is an inductor? So before going towards the definition of an inductor, let's have a look briefly into the history of an inductor. So it was Hans Christian Ørsted. In the early of 19th century, he found that a current-carrying conducting wire has a magnetic field around it. And he proved this by putting a compass near the current-carrying conducting wire. So the current-carrying conducting wire deflects the needle of the compass towards it. So from this, he concluded that the electricity produces magnetism. Now to find out the direction of the magnetic field around the current-carrying conducting wire, we can use the right-hand rule, which states that put the thumb of your right hand in the direction of the current and curl your fingers, so the fingers will show the direction of magnetic field around the current carrying conducting wire. Now if you turn this wire into a single turn, then the magnetic field will be exist through the center of this coil. Now if we turn this wire into more than a single turn, then there exists a coil like this shape. So the magnetic field will be exist through the center of this coil and around the coil, and the strength of the magnetic field lines will be more through the center of this coil as compared to outside the coil. And this coil is basically known as an inductor. And we define this inductor as the component which is used to store energy in its magnetic field. Now, according to Micheal Firaday's law of electromagnetic induction, the voltage will be induced across the coil if the current through the coil changes. So if the current through the coil changes with a specific rate, then as a result the voltage will be induced across the terminals of this coil. And this voltage induced is directly related to the rate of current through this coil. So as the rate of current through the coil increases, the voltage induced will be increases. Now to remove the sign of proportionality, the self-inductance of the inductor will be involved to remove the sign of proportionality, where this L is basically the self-inductance of the coil. And this self-inductance is defined as the inductance level in any inductor determines the strength of magnetic field around the coil due to an applied current. So if the inductance level of any inductor is high, then as a result the voltage induced will be high. And the unit for this inductance level is the unit of inductance is Henry, which is represented by a large symbol H. And we also use microhenry, millihenry, etc. to measure the level of inductance of any inductor. Now to find out the direction of induced current in the coil, we can use the Lenz's law, which states that now according to Lenz's law, the induced voltage across a coil will always oppose the cause that produced it. Now to understand this law in a more brief way, let's take an example in which we have an AC voltage source which is connected in series to a switch and a resistor and an inductor. Now initially when this switch is open, there is no current flowing in this circuit. So as a result, there is no voltage induced across the terminals of this inductor. Now at the instant when the switch is closed, a current will start flowing in this circuit with a specific rate. Let's say in this direction. So as a result, the voltage will be induced across the inductor such that to oppose the cause that produced it. It means that the polarity of the voltage will be in a manner to oppose the original current in the circuit. So conventionally, the polarity will be like this. The upper side will show the positive terminal and the lower side is the negative terminal, because conventionally the current induced due to this induced voltage will be in this direction to oppose the original current in the circuit. Now according to Lenz's law, we can write down this equation in the form V is equals to minus L di divided by dt. This negative sign represents that this induced voltage will always oppose the cause that produced it. So it's all for today's presentation. In the upcoming presentation, we will be discussing some important points about the inductor. So if you have any doubt, ask in the comment section. See you in the next one.